So hello everyone, welcome. It's nearly coffee time, so try not to keep you too long. So I'm going to talk a little bit today about the challenge of safely evolving APIs, the relationship that exists between API consumers and API producers, and the expectation that exists on both sides. So this is a safe space, so maybe just a little show of hands. Has anyone here ever broken an API on one of your consumers? I definitely have. And what about on the flip side of that? Have you ever had an API that you depend on or your client implementation requires? Break your implementation without any communication from the provider. Okay, cool. So we're all in the same boat. So both hands. Very good. So a bit about me. Probably heard me already today. My name is Frank Kilcommins. I'm an API technical evangelist at SmartBear. I'm a developer, software architect by trade, I guess. And I'm very passionate about APIs and the overarching developer experience that comes with APIs. So to explore some of the challenges, what I'll do is I'll take a quick look at what's happening across the API landscape and why things are probably going to get harder. And then we'll see how can we kind of design for future promotion and maybe look a little bit critically at good design practices and good extensibility practices, and is that enough? And I guess the TLDR version of this talk is probably not. So I'll introduce something called bi-directional contract testing as a potential approach to help. Have a quick demo-ish. So I didn't trust the demo god, so it's a demo-ish. And hopefully you can go have some coffee with at least a high-level overview as to what bi-directional contract testing is, and be curious to learn a little bit more. So you would have seen some of this today in the keynotes, both from Gene and from Mark and Mike, but microservices are everywhere, and they're one of the main catalysts driving API growth. So it's coming back year on year in the state of software quality reports for APIs that we do at SmartBear. It's also coming back in the state of API reports that our friends over at Postman produce. So it's really everywhere. And microservices themselves are coming out of the trough of disillusionment. So they're no longer a fad. We're all on this journey moving away from monolithic architectures toward more consumable-based, capability-focused architectures where microservices are very well suited. We're all on about unlocking the value that's hidden away in internal systems, making it easy to discover that, making it easier to reuse and consume that. And we've also heard about API sprawl, and Jeremy was talking about this in the talk that has just finished. And when it comes to managing our APIs, things are probably going to get a little bit more difficult. So Gartner are telling us by the year 2025, less than 50% of enterprise APIs will fall into what we call traditional API management practices. And we all rely quite heavily on API management and gateways today to deal with APIs, be it acting as that nice catalog where we can go to discover our APIs, asserting base levels of quality. So making sure that we take care of security, making sure we have good API documentation, and perhaps even more importantly, acting as that known place that we can go to find out the relationship between consumers and APIs. So who's consuming what, who is depending on what, and giving us a very kind of standard way to go about authorizing access to APIs. So if you're not feeling any pain with your API management processes today, you probably will. So with the more microservices that come about, we will start to potentially see more of them fall into this kind of shadow state, even a potential zombie state. We won't be maintaining them too well. Security vulnerabilities might start to happen. And the cognitive load for keeping track of all of these relationships will fall onto the teams. Over time, that will wane, and kind of the blindness that can happen because of that has several implications. And the one I'm going to focus on today is it's going to make the safe evolution of our APIs harder. So one of the fundamental ways that we do our best to not break our APIs and to evolve safely is to have strong design practices. I think there's a lot of design-first advocates here today, and it's all about making sure we get quick feedback and agreements on what we're going to do before we go and do it. And the earlier we can bake extensibility practices into our design kind of machine is very good. And some of this is inspired by a talk from Eric, who's just showed up, and he has some very good material on evolvability and extensibility for APIs. And kind of a cheat sheet for how we should go about doing that is thinking about our microservices the same as we do thinking about traditional APIs that we expose outside of our organization. So thinking about them from the outside in, putting the needs of the consumer front and center, so making sure that we have things like good API documentation, that we leverage specifications like OpenAPI to describe our APIs, and then treating them like a product. So effectively making sure that we put discoverability, usability, usefulness, and usability as focal points to promote reuse. If we wanted to get a little bit more tactile about that, and Jeremy alluded to this a little bit as well, is we need to focus on where we're going to extend our API. So define our extension points. So don't be afraid to communicate to consumers to say, hey, Miss Consumer, this part of the API, it's pretty rock solid. We're not expecting to change this too much. But we have an MVP part over here. That's going to be a little bit more volatile. Expect there's going to be some changes there. And then communicate how you expect consumers to deal with that change. So define a good extensibility pattern. And must ignore is probably the most well-known and well-used out there. And that's where you say, dear consumer, if you encounter something you don't understand, then you must ignore it. You must not break. You must ignore it. And we'll do our part on the provider side to make sure it's going to be a backwards compatible change. It's not going to materially impact any other part of the API that has pre-existed. Having good, well-defined versioning is also something that makes the consumer life easier. Semantic versioning is probably the most common out there, and that just sets the stage with regards to how you deliver patches, feature enhancements, and breaking changes, and then communicate. So for every one of these things, use it as a way to communicate and bring your API consumers along your journey with you. On the don't side, I'm not going to read all of these out. They're pretty self-explanatory, but don't add required inputs. If you have a property that's a string today, make sure it's not an int tomorrow, for example. And probably jumping to the last one, which I think is potentially the most important, and that's don't be inconsistent in your process. So when you're dealing with APIs, it's not about the first time through that cycle. So you're working with a product. As soon as it's in production, it has consumers. So make sure that every time you go through that cycle of delivering some change, follow a consistent process. And optimally, you will get to the place where you can follow a consistent process across your full API portfolio. So is this enough? Can we rely on good design practices? Can we make sure that extensibility will make sure that we will never break a consumer implementation? Well, unfortunately, probably not. So you can only achieve so much with interface design, no matter how good it is. And I think another interesting finding from Postman's State of API report this year is that actually API design skills are in short supply. So making sure that you have the talent within your teams to make sure that you can safely and extensively evolve your API is becoming harder. But this isn't to say that you shouldn't do this. You absolutely should follow some of these recommendations, because good design and good extensibility allow us all to hope for the best for a considerable period of time. But with the acceleration of API growth across the whole landscape, we need to also prepare for the worst. And we need to be aware of something called Hyrum's Law. And I imagine quite a few here are familiar with that. Yes? No? Well, I'll paraphrase. And it's that with a sufficient number of users of your API, it doesn't matter what you promise in the interface design contract. All observable behavior of the system will be depended on by somebody. And that happens. That's absolutely what happens in the real world. And because of that, it can cause a bit of a paralyzing effect on the provider team. So as you begin to lose insight into how consumers interact with that surface area of your API, so you have this big definition, maybe hundreds of endpoints in there, you're not quite sure what is being consumed by who. You can only assume that everything is being consumed. And because of that, you may also not even be aware you have certain consumers at all, which also happens. So what do? Well, instead of risking breaking an implementation, you bump a major version. So we have a problem with major version proliferation. And that can be a bit of a knee-jerk reaction, of course, but it's what is happening when you lose track of how consumers interact with your endpoints. And the cognitive load, again, of kind of dealing with multiple versions is a very costly one. So you have to maintain multiple similar but slightly different versions of the same API. Certain new features might have to get into multiple versions. Other new features might only have to get into one. And it's the teams who are bearing the brunt of dealing with all of this complexity. Even when it comes to testing all of these multiple similar but different versions of an API, it's going to incur actual cost for you every time you go through that iteration. And maybe zooming in on testing a little bit, and this is a pretty simplified diagram, but let's assume that as part of my migration towards a more microservices architecture, I am still employing end-to-end testing. That is not going to fit so well or give me the return on investment that I would expect. So in this instance, I have a consumer component, and for every simple change I make to the consumer component, if I'm employing end-to-end testing, I have to stand up all of the underlying infrastructure to be able to give me feedback. Is it safe to move this change and promote this change towards production? So if you have this kind of what I would call an unbalanced approach to testing for your microservices, it becomes very expensive. So you have to maintain all of this context, all of these underlying components. It also becomes slow to get feedback. So you have to spin up quite a lot of stuff to get feedback on, is it safe to make this little change to a particular microservice? It's also unreliable. So you get into a situation where sometimes the tests pass. The next time you run, the tests fail. So what do? Well, you run them again, and then they pass. So teams start ignoring failures, and that kind of completely defeats the purpose of having the tests in the first place. They're also not targeted. So you're making a very small change to one component, but you have to spin up a very complex test suite in order to get feedback on can you make that change. Related to this, it also brings us on to the challenges of managing dependencies and environment management with this unbalanced testing approach. So here's a very, very simple overview of two independent CI pipelines, one for a consumer and one for a provider. So when I say CI, I think continuous integration, so GitHub Actions, Azure DevOps, pipelines, Jenkins, and so forth. And here it's across three environments, so a very simplified view. You can see that there's different versions of consumers and different versions of providers on the different environments. So I'm in the practice of promoting some change towards production. And what you might expect is that I would want to check at each point within these environments that the versions of the consumers conform to the versions of the providers that are in that same environment. So if, for example, I was to test on the CI environment and run tests between consumer v3 and provider v3, if those tests pass, I can be quite confident that these components communicate together. And if other tests pass, maybe security tests, maybe performance tests, then potentially we can promote this towards production. But of course, the very essence of microservices and indeed componentization in general is that I don't want to have to move all components at the same time. So what if I wanted to promote consumer v3 towards staging? What else would I need to check? Well, obviously, I would need to then check that consumer v3 is compatible with provider v2, which is on staging. And similarly, if I wanted to promote consumer v2 on staging to production, I'd have to also make sure it's compatible with provider v1, which is currently deployed to production. The inverse of this, what if I wanted to move the provider without the consumer? So I'd have to make sure that the provider v3 is compatible with the consumer v2 in staging, and so on and so forth. So you can see that quite quickly, you can have a very complex setup to be able to manage the dependencies between components so that you can test out the interactions that depend on each other while still trying to maintain some form of flexibility so that you can promote feature enhancements and bug fixes without having to move all components in lockstep. And what I'm going to talk about is kind of contract testing, and specifically bi-directional contract testing is something that can really help with this. But before I move on to that, let me just plant something in your head, and it's from one of my colleagues, Beth Scurry, who's the co-founder of Pact and Pact Flow. And what she says is if you can't deploy services independently, you don't have microservices. And not alone that, you probably have a very costly approach to asserting quality, and you have what we call a distributed monolith. And just in case I'm not saying it, that's a bad thing. So you don't want to get into this situation. So what can we do to potentially overcome some of the pitfalls that we've talked about up until now? Well, one approach is bi-directional contract testing. And this is one that also rewards your investments in a design-first practice. And perhaps you're coming at this with some familiarity of Pact open source and maybe consumer-driven contract testing, but this is a slightly different workflow. So it's schema-based rather than specification-based. It's also very well suited to a design-first workflow, as I said, and it's well suited to retrofitting onto existing systems. So by that I mean it can give you an opportunity to kind of upgrade your existing tools and processes into a contract testing solution, because you can get return on investments on existing technology choices that you've made in your landscape. So you can reuse artifacts like an OpenAPI definition. You can also leverage potential mocking tools that you have, like Cypress, like WireMock, for example. You can bring your own functional testing tool. So be that Ready API, Dread, Postman, and you can use these to actually help you. You don't need to make big technology investments to get started with bidirectional contract testing. It's also a more inclusive form of contract testing. So from a consumer-driven contract testing approach, that is more limited to just the development team because it fits into the unit testing phase of the process, which means you need access to the code. But from a bidirectional contract testing perspective, you don't. So it's supporting a wider demographic of testers. So when I talk about a pact, what is a pact? Well, the formal definition is that it's an agreement between individuals or parties, and in this instance, it's between API consumers and API providers, so between two software components. And when I refer to pacting kind of in terms of contract testing, I mean the artifact that's acting as this verifiable contract between two component pairs, two software component pairs. I do not mean the OpenAPI definition. The OpenAPI definition is the full contract of what a particular provider can do, but that's not an agreement between a specific consumer and a specific provider. So what it does effectively is that it captures the interaction between a consumer and a provider pair for one single integration. So I no longer care about all of the downstream dependencies or the upstream dependencies. I care on one integration at a time, and I care about the expectations on both sides of that, so between the component pairs. And what's interesting about it is that it keeps assumptions in sync. And for anyone that's kind of using mock testing or other forms of test doubles, one of the risks that you can experience is assumption drift. And there's a quote by a relatively famous tester called Joe Wallens, and it's, "Don't mock what you don't own." And one of the reasons is because as soon as you do that, your assumptions get stale quite quickly, and it can mean that you are making false assumptions about how the other side of that particular integration works. And bidirectional contract testing works a little bit different because it will verify those assumptions on both sides of the integration. That can happen in an asynchronous fashion, and eventually when both sides are verified, you have a pact that is verifying this agreement between these two parties, so you can be quite confident when they communicate in real life that you will not get any surprises. And in a pact file is this type of JSON structure. So it lists who the consumer is, it lists who the provider is, it lists the interactions, so what the consumer expects of the provider, and it contains some additional metadata. And for anyone who was able to read that small text, there is a reference in there to a Pact specification. So there is a specification to describe the structure and the format of what will get into a Pact JSON file. So how it works is it generally starts on the provider side. Now, theoretically, it can start on either side, hence the name bidirectional, but this is much better suited to starting on the provider side. So you can bring your OpenAPI definition of your interface. You can then bring your own functional testing tool to validate that the implementation does what you say on the tin, so that you actually have implemented what you promise in the OpenAPI definition. Once you have those proofs, You can then publish those to the broker, in this case to Pact Flow. Then on the consumer side, the consumer can validate their implementation against a mock. So you can bring your own mocking tool. As I mentioned before, you can, of course, use the Pact DSL, but you're not forced to do so. And once that's done, you serialize those expectations, those kind of unit tests into a consumer contract, and again, you publish that to the broker. Once both of these have been published to the broker, then within Pact Flow, we can use something called the Can I Deploy tool, which will effectively perform this cross-contract verification or contract comparison. And that's basically performed, and that's the quality gate that will determine, is it safe for me to move the change that I'm proposing upstream into the next environment in my pipeline? And for that to happen, every single party that integrates with that has to be supported by this version of the contract. And what Can I Deploy kind of uses or queries to make this decision is what we call the matrix of information. And this contains all versions of the API consumer, all versions of the API provider, all integrations between all versions, which ones are compatible and which environments they have been deployed to. So that kind of complex dependency that I showed you a little bit earlier with a very simple pipeline, maybe in the past some of us have had experiences with change advisory boards who would be maintaining all these versions of software that are in different environments or configuration management teams. But this Can I Deploy check queries this information, and you get instantaneous feedback on, can I actually make this change? Is it safe for me to make this change? So here's a demo-ish of how it works, and I say ish because the GitHub actions were taking a little bit too long, so I didn't want anyone to wade through that. So I have a very, very simple provider, which is generating a products API written in .NET, and I'm bringing my own testing tool. So I'm bringing Schema Thesis to test that my implementation is honoring the OpenAPI definition. On the consumer side, again, I was lazy, so this is, again, a .NET consumer, but that's irrelevant. And I'm bringing my own mocking tool, in this case, WireMock. And then I have two independent CI pipelines, so using GitHub Actions for that, one for the consumer and one for the provider. So a very simple products API, 3 endpoints: get products by ID, delete product by ID. And then once I have this defined, I'm going to validate and I'm going to test that my implementation is honoring this definition or document describing my interface. So I run the Schema Thesis tests against my code, and they pass because I have indeed delivered the API implementation as I had designed. So now I can run my CI pipeline. So this is the first time through the CI. So the Can I Deploy check passes because it can't find any consumers, so I expected it to pass. So I'm able to deploy my API into production, and I'm able to publish the provider version of this contract to the broker. So this gets published to Pact Flow. So this is just a little bit what Pact Flow looks like. So I see 3 question marks for the consumer. So first time around the process, I don't have a consumer. I have a provider contract, and you can see a representation of the provider contract. So it also shows me a representation of the OpenAPI definition. And now I'm going to move on to the consumer side. So I'm going to show you kind of the unit tests validating my consumer implementation. So this is just standard unit testing. I'm using XUnit here, very standard structure, an arrange, an act, and an assert. The mocking tool I'm using is WireMock, and I'm taking advantage of the fact that there is an adapter between Pact and WireMock to allow me to serialize this test. So this is testing that if I invoke the get product by ID for a fictitious product ID, I expect I will get back a 404 not found. And that's what gets serialized into the Pact JSON file. So you can see the consumer and what its interaction expectations are. And this is looks the same, but this is the consumer pipeline. So first time through the process, the Can I Deploy check is verifying that the interaction expectations that were in that Pact JSON file are honored by the provider contract. So what it's effectively doing here, because it is specification based on the schemas is it's making sure that all of the interaction expectations of the consumer are a valid subset of everything that's supported by the provider. So it was able to match that even down to the field level. So it knew that my provider OpenAPI definition supported a 404 not found for that particular endpoint. So now when I look at the updated version of this in the broker, I now have a pact between my consumer and my provider. Both have been deployed to production, and I can see the interaction expectations that were validated on the consumer side. So that all goes swimmingly well first time around the cycle, as we would expect. So we're getting ready for coffee, and then the product owner comes to me and says, "Hey, Frank, great job on deploying that API, but I see you put in a delete method, and we only want that for the administrative API, which our inventory system is using, and not that client, which is showing our product catalog towards the consumers. So can you remove that endpoint from the API, please?" And I'm going to go, "Oh, this is a breaking change. I have to remove an endpoint. Surely this is going to break. I can't do this." And what this can I deploy check allows me to do, it allows me to have a more pragmatic approach to how I address these breaking changes. And because I have full insight into all of my consumers and what parts of the API surface area they're consuming, I'm safely able to make what would be traditionally a breaking change. And I can do so safely, and I don't have to incur the cost of bumping up a version just because I want to be dogmatic about my versioning strategy. So I make this change, I rerun the pipeline, and because the can I deploy check will again validate that I can honor all of the consumer interaction expectations, it knows that my consumer is not consuming this endpoint, the check passes, and I'm allowed to deploy this into production. And that pact is still valid. So the pact that I had with that consumer in the broker is still valid, and all that's been updated is the provider contract. So you can see that the delete method is gone. Now, it's easy to believe all green checks when you see them, but what would happen if I was to make an actual breaking change? Well, the can I deploy check would prevent me from doing it. So in this instance, the product owner is saying, "Hey, we're getting screwed by our metrics. I created some cool reports for our executive team, but client errors are showing like actual errors, and it's making us look bad because there's so many calls for products that don't exist. So can you maybe change it from a 404 response to a 204? Maybe no one will notice." But luckily, I'm prevented from making that change because it will break the expectations that a client has with that specific endpoint. And you can see the details of that in your CI pipeline or even directly from your development machine if you wanted to wire it up. And you also see it in the broker itself. So you see that this failed, the contract comparison check did not pass, and you see details about it. So you see a consumer was expecting a 404 for the specific path that's referenced there. And the matrix of information is updated. So we can see that the latest one failed, and you see NA for the environment, so it prevented me deploying that change into production. And all of that information is maintained as part of that matrix. So hopefully you can see that if you can introduce contract testing into your testing strategy and into your development approach towards microservices, you can rebalance the testing pyramid, so you can reduce your dependency on end-to-end tests and on integration tests, and most importantly, you can reduce those assumptions which help you deliver with confidence, and you have an approach that's cheaper, you have one that's faster, it's very reliable because you have that insight and you get that feedback back incredibly fast, and it's very targeted, so you don't have to spin up a whole underlying infrastructure just to test one thing. And it also really kind of advocates for your design-first approach. So one of the challenges with design first is it's very easy for us to do it kind of first time through that cycle, but as soon as we have a sufficient number of consumers, we're losing insight, it's harder for us to make those good decisions without having to bump our versions. So it allows, as I mentioned a little bit earlier, we can have a more pragmatic approach to versioning. Now, situations will always occur where you will want to make a change and it will be breaking and you will be prevented from making that change, but that's okay. Because you have the insight into who you are breaking, you can actually have a conversation with those teams, and you can very practically decide, is it better for us to create a major version in this instance, or can we work together to get this change out the door without incurring the additional overhead of another version. So you have the insight to have those good conversations with other teams that are depending on you. And with that, you can design first with confidence and not break APIs. So thank you very much. Any questions? Sure, yeah.
Yeah, Frank, in a place that I run, very strict on versioning definition, what is a minor version change, major breaking. And I know maybe I missed part of it, but I still always had the problem when I updated and just extended the scheme, extended the model, added a new element. The job on the receiving side was ignore anything you don't understand. There's a new element there. Well, that still proved to be a problem. But some people, the way they wrote their code, would just break, supposedly a non-breaking change, because they just couldn't resist to look at an element or a value they hadn't seen before. I mean, this would still be a problem if they're not following good engineering practices, following this approach.
So just to kind of paraphrase Stuart's question, so he asked if consumers were not adhering to the extensibility pattern that you had communicated and they were still breaking if you added an optional change, can this approach or can bidirectional contract testing help? It can, because the consumer verification is supposed to be very explicit. So it's built into your unit testing. So you have to document what your interaction expectations are for the endpoint. So you can't write a unit test to really expect something from an endpoint if it doesn't exist. That really should fail your unit test, I would imagine. And even if it happens to pass that, it would be part of the interaction expectation that would be recorded into that contract. So the can I deploy check should spit that out. But if situations like that occur, again, that's potentially down to the fact that consumers are just not following those extensibility patterns and recommendations. And that's why it's always a good practice to, every time you are rolling out a non-breaking change, make sure you are curating a change log. And I think that often is skipped, but make sure you are, and make sure you use that as a mechanism to communicate with all of your consumers. So sell the benefits of this new little feature that you've added and why you've added it, and make them aware that they're X number of versions behind the latest minor version, and try and pull them along with you. There's nothing like people seeing a capability that might be interesting to whet their appetite. Yep.
State behavior often depends on state. How does Pact?
So the question was, how can we deal with state and managing the different state of the consumers to make sure that the provider is honoring it? Is that more or less the...
At the server, the behavior of your service depends on state. So how does that be captured?
In the consumer-driven world, it's up to the provider has to maintain those states. They're called provider states, to be able to honor the consumer tests, which is a little bit heavier, and that's one of the challenges with consumer-driven contract testing, because it's a bigger load for the providers to have to deal with, so it doesn't scale very well to have to kind of maintain all of that state. With bidirectional contract testing, we're not doing it based on specification by example, which requires that state to be there. So this is, it's a schema-based comparison. So it's always verifying that the consumer is a valid subset of what's honored by the provider. It does that down to the field level, and it verifies at least down to the type. But if you're expecting a specific string to be returned in a specific property, it's not going to give that for you, but it's going to say that this is going to return a string, and we can see that the consumer is expecting a string, so that should work. So it's kind of the 80-20 rule. It's not going to cover all of the edge cases where maybe you have very specific enums, like real exact enum matching is something that's planned, but it's not supported right yet. Yep.
So sometimes handling like already a single API specification like an API can be challenging to only handling tens or hundreds of API specifications in a microservice architecture can also be very challenging. So in this case, we're talking about handling, so to say, third interactions, so service to service. So my question is, can you really end up with a problem with a third explosion? If you think about it, microservice architectures like this, tens or hundreds of services. Now we're talking about interactions between pairs of services, right? So there could be like hundreds of thousands of interactions. So is it possible to handle these cases?
Right now it is. So this has been tested to a pretty sufficient scale and working quite well. And again, the beauty here is that it's a little bit lighter than the consumer-driven one because you don't have to deal with all of the specific provider state that is required to honor all of the interactions. It's at a lighter level, so it's more based on the schema. But it's always focusing on one specific component is the provider, one specific component is the consumer, and it's just verifying that interaction between both sides of that integration. So you might have 1,000 microservices, but for any one of these things, you're only ever focusing on that contract between one consumer and one provider, and it doesn't really care about all of the other stuff that's there. That's not going to get queried or validated as part of the can I deploy check, so that's always very, very fast. Does that answer your question?
Yeah, still my point is you can actually end up with like tens or hundreds of services. You can actually end up with thousands,
Yeah.
tens of thousands of, so to say, Pact specifications.
Yes, but scale will always be a challenge. I don't know what threshold has been tested. It is quite sufficient. We probably even have that information on the PactFlow website. I'm sure there's probably some kind of scaling limits that have been set there. But we don't expect people to create Pact specifications by hand. So that's the other thing. So you don't craft these by hand. They are to be crafted more by the machine. So you will serialize your expectations against your mock testing on the consumer side automatically to the Pact. So there's adapters there for several mocking tools, and it's an extensible framework. So you can, if there's something that's not supported, you can add your own adapter. Yeah. Any other questions? I mean, because Eric's here, I recommend everyone checking out that YouTube video at the bottom there. It's a very good one. Thanks, everyone.